Alright, so let's talk about difference of squares, and the next video will be about sum and difference of cubes. So we've started talking about factoring, and the first step of factoring is, of course, to find GCF. So I want you to write up in the corner, alright, if there is a GCF greater than 1, deal with that first. So the first thing that you should check for in any factoring problem is whether there is a greatest common factor greater than 1 and any common variables associated with it. Alright, after that, we're not just working with any polynomial now. This lesson was all about binomials. Binomials have two terms, so a binomial has two terms. And if the binomial is a difference, meaning it's subtraction, of two perfect squares, then we can use the following formula to factor it. Let me see if I can zoom in. So we can express the difference of squares as a squared minus b squared, where a squared and b squared are the two perfect squares. This could either be a variable with an even exponent, so a variable with an even exponent is a perfect square, or it could be something like 4, because 4 is 2 times itself. So a number that you can get by multiplying something by itself is also a perfect square. If you have two perfect squares and they're being subtracted, you can factor this as a minus b times a plus b, where a and b are the square roots of the perfect squares. So for this first one, x squared minus 36, we have x squared is our a squared, and 36 is our b squared. X squared and 36 are not a and b, they are a squared and b squared. So in order to find a and b, we need to take the square roots of x squared and 36. So the square root of x squared is x, because x times itself is x squared. And the square root of 36 is 6, because 6 squared is 36. So our first factor is going to be x minus 6, and our second factor is going to be x plus 6. And you can check this, and you'll see that you will get x squared minus 36 back. You can check this using FOIL. So if you remember FOIL, first, outer, inner, last, you would get, and I'm just going to do this off to the side just to check, x squared, then the outer terms, 6 times x, plus 6x, the inner terms, minus 6x, it's negative 6 times x, and then negative 6 times 6, 36. These two cancel out, and you're left with what you started with. Okay, so now y squared minus 49. We're going to do the same process. The square root of y squared, the square root of y squared is y, and the square root of 49 is 7. So a is y, and b is 7. So my first factor is going to be a minus b, and my second factor is going to be a plus b. We can also check this with FOIL, but that'll take too long, so I'm going to skip it. Okay, 4x squared minus 21, or minus 121. We have a difference of perfect squares here. 4x squared is a perfect square because 4 is a perfect square and x squared is a perfect square. X squared is a perfect square because it has an even exponent. So 4x squared, the square root of it is what we would have to multiply by itself to get 4x squared, and that would be 2x, because 2x times 2x is 4x squared. Now 121, its square root is 11, so we get minus plus. 2x minus 11 is our first factor, 2x plus 11 is our second factor. And this is the factored form. I guess I should start putting equal signs here. Okay, feel free to jump ahead and pause the video if you get stuck. Feel free to rewind things if you didn't understand it the first time. So we're going to rewrite 9x squared minus 16y here, or 16y squared here. The square root of 9x squared is 3x, because 3x times 3x is 9x squared. The square root of 16y squared is 4y, because 4y times 4y is 16y squared. That's minus, that's plus. X to the 6th minus 144. X to the 6th has an even exponent, so because x to the 6th has an even exponent, it is a perfect square, even though it does not say squared. But what is its square root? Well, to find the square root, we divide it, the exponent by 2. Because if you think about it, x to the 6th is 6x's being multiplied, which is the same as x cubed times itself. So x to the 6th is x cubed times x cubed, meaning that the square root of x to the 6th is x cubed. You can again get this by chopping the exponent of the original perfect square in half. All right, 144, the square root of that is 12, minus plus, there's our factored form. 25x to the 10th minus 81. Okay, real quick before we continue. There's no greatest common factor between x squared and 36. There's no greatest common factor between y squared and 49. There is no greatest common factor between 4x squared and 121. And the same goes for all of these that we've done so far, because there is no common factor besides 1 that can go into both terms of all 5 of the binomials that we've worked with so far. So it's important to check whether or not you have a greatest common factor between the coefficients. With common variables, it's a bit more obvious to see, like we would only be able to factor out a common variable if this had an x on it, for example. If this 81 had an x on it, then we would factor out a common variable. But we have to check to see if 25 and 81 have any common factors. So I want you to take a second and do that. And if you tried it, you'll see that there is no common factor, just like the other 5. So now that we know that there's no greatest common factor, now we can do difference of perfect squares. We should get 5x to the 5th, 5x to the 5th, and 9. For the next one, let's again check for a GCF. So we have 2 and 200. Is there a greatest common factor here? There is. It is GCF of 2. The greatest common factor is 2, because 2 goes into both 2z squared and 200. So before we do anything, we need to deal with that GCF. 2z squared minus 200, we are undistributing a 2, so we're going to cut a 2 from both of these. We're going to cut off a 2 from both of these terms. So when we cut out a 2 from 2z squared, we're going to get just z squared. When we cut out a 2 from 200, we're just going to get 100. And now that GCF is now out of the picture. It is now completely factored. So we have to remember that it's there, but don't do anything else with it. We don't do anything else with it unless something else is in here that we can factor out, which there isn't. But yeah, because this 2 is now factored out, we don't have to do any more factoring with it. So the only factoring that we have left to do is with this z squared minus 100. So we are going to get 2 as our GCF, and then we're going to factor this z squared minus 100. Z squared is a perfect square, 100 is a perfect square, we can do difference of squares. Z is the square root of z squared, 10 is the square root of 100, minus plus. That is our factored form. 2 times z minus 10 times z plus 10. It has 3 factors. Alright, now for this one, x to the 4th minus 16. Is there a greatest common factor that is greater than 1? Take a second. There is not. We don't consider the exponent here because the only factors that go into x to the 4th are x, 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 and x. The only factors that go into 16 are 8, 2, 16, 1, and 4. Okay, so there's no common factors between these. However, they are perfect squares. Alright, so now we have x squared and 4 minus plus, and hang on, look at what we have right here. We can only stop factoring when both parts are unable to be factored further. Now keep in mind, we have two perfect squares for this term as well, but there's a plus in the middle. We don't know how to do sum of squares yet. Sum of squares is a thing, but it is not going to be a thing until next unit, so we don't have to worry about it. X squared minus 4, however, is a difference of squares, which means we have to rewrite that x squared minus 4 in its factored form. Now we're going to keep the x squared plus 4. Don't forget about it. Don't forget about it. It's still there. This x squared plus 4 is still there. But we have to rewrite x squared minus 4 in its factored form. So that's going to be the square root of x squared, which is x, the square root of 4, which is 2, x minus 2, x plus 2. And there are three factors. So this factored form has three factors: x minus 2, x plus 2, and x squared plus 4. Alright, I'd like you to work on the sample problems on your own.